Welcome back to our next video. So in this one, we're working question number 4 of the 2017 Unit 2 past paper. So it starts out by asking us to define the terms primary, secondary, and tertiary as applied to alcohols and give relevant example. So primary alcohols, the carbon atom, as we know, the OH group is going to be attached to a carbon atom. So what we do is pay attention to the carbon atom that the OH group is attached to. So if the OH group, as it says here, is attached to one alkyl group, or if you want to say one carbon atom, then it's a primary alcohol. And we know that alkyl groups are CH groups. All right. So CH3. All right, so this is methanol. You can see that the OH group is attached to one carbon atom. Next example is ethanol. So again, if the OH group is here, it is attached to one alkyl group, which is CH2, CH3 ethyl group, or we can simply say it is attached to one carbon atom. So let me say that again. The OH group, so the carbon atom bearing the OH group is attached to one carbon atom. But in methanol, because it's just one carbon making it up, all right? There are no other carbon atoms present. But in this one, we see that the OH group attached to this carbon, it is attached to one carbon atom. So based on this definition, you wouldn't draw this one. You would draw ethanol, because the carbon atom bearing the OH group is attached to one carbon atom. Here, the carbon atom bearing the OH group is not attached to any other carbons. So by definition, you are given an example, you don't want to give this one. All right. So the OH group attached to this carbon, all right, it is only attached to one other carbon atom. So again, you could also have propanol, one propanol, that is, reason being, the carbon atom bearing the OH group. And so this is the carbon atom that is attached to the OH group. So it must be connected to one carbon atom only. All right. So as you can see, for one propanol, the carbon bearing the OH group is directly attached to one carbon atom. If you want to say alkyl group, this is one alkyl group. So the carbon atom bearing the OH group is attached to one alkyl group. Or you say it is attached to one carbon atom because it is directly in contact with one carbon atom. So you would draw the structures, of course. So you would put on the rest of your hydrogens. And it said give relevant examples using structural formula, right? So ethanol and one propanol are examples. Ethanol, one propanol. Right? So those are primary alcohols. I'm going to let that one remain. Now for secondary alcohol, the carbon atom bearing the OH group, it is attached to two other carbon atoms. So notice here, this is the carbon atom bearing the OH group, and it is attached to two other carbon atoms. All right. So that now is secondary alcohol. So once it is attached to two other carbon atoms, it's a secondary alcohol. Notice the carbon atom with the OH group. Let me use a different color. See if I can just erase the carbon itself. So the carbon atom attached to the OH, it is only touching one carbon atom, which is this one. But this carbon atom here, it is touching this carbon, and it is also in contact with this carbon. So when that happens, it's a secondary alcohol. You could also look at it in terms of, I don't want to give it too much, but you can look at it in terms of hydrogens. I prefer to actually use hydrogens because the reason why oxidation of alcohols can take place is because of hydrogens. So if the carbon with the OH group does not have a hydrogen, it cannot be oxidized. But I will leave that for oxidation of alcohols. But I'm just pointing that out from this video. If no hydrogen is attached to the carbon atom with the OH group, oxidation will not take place. All right, so just back to answering the question. Two carbons are attached to the carbon atom bearing the OH group. These groups are also called alkyl groups. Hence, in the definition, you say I put alkyl group / carbon atom. All right, let's do a next example. So all I'm doing here is increasing the amount of carbon atoms. So let us name our alcohol. Okay, and notice, if you notice, all right, it's here for this alcohol, if we are naming it, let me put it here, this would be called 2-propanol. So any other number other than a 1, because if we're naming this one, it is 1-propanol, meaning the OH group is at the end. So for primary alcohols, the OH group is always at the end of the compound. So once you have a 1 indicating the position of the OH group, that's a primary alcohol. This here is 2-propanol, indicating it is within the chain. So that carbon atom will be flanked by other carbon atoms, making it secondary. This one also is 2-butanol because the OH group is on carbon 2. Let me just put a hydrogen on this one. So that is 2-butanol. So primary, it is attached to one carbon atom. For secondary, the carbon atom with the OH group is attached to 2 other carbon atoms. And now for tertiary, the carbon atom with the OH group is going to be attached to 3 other carbon atoms. So let's just put 1 carbon there, 1 here, and 1 here. So the carbon atom attached to the OH group, it is attached directly, as you can see, to 3 other carbon atoms. All right, so it's not about the amount of carbon atom in the chain. It's the amount of carbon atom it is directly touching. So it is in contact with 3 of them, So it's a tertiary alcohol. And the name of this one is 2-methyl 2-propanol. Right? So this is tertiary, these two are secondary, and this one is primary. Part B of the question now, it says 2 isomeric alcohols. Hold on, I left the part. Right, so the question says 2 isomeric phenyl alcohols A and B on treatment with concentrated sulfuric acid. So we have 2 isomeric phenyl alcohols, and they give us the molecular formula C8H10O. So this is on treatment with sulfuric acid, produce compound D, which decolorized a solution of bromine water. So this should immediately be giving you some hints. So you have the alcohol, you react it with concentrated sulfuric acid, you get an organic compound that decolorizes bromine water. Once you hear decolorize bromine water, you should be thinking about the alkene, right? There's no mention of UV light, so it couldn't be alkane. Also, it's a reaction of alcohol, and you would not have done any reaction in which you would obtain the alkane from an alcohol. Also, this reagent, concentrated sulfuric acid with your alcohol, you should know that that is a dehydration reaction. So you have the alcohol, you treat it with concentrated sulfuric acid, and you get a compound that decolorizes bromine water. It is telling that compound D is an alkene because you have just dehydrated your alcohol to form an alkene. So that's one part of the question. Now, this other part is not following on with the dehydration. So it says oxidation of the 2 isomers with potassium dichromate produce compound E and F. So this is a next reaction of the alcohol. The first one was dehydration. This one now is oxidation. So you oxidize the alcohol, you get 2 compounds, E and F, which both give yellow precipitate with Brady's reagent. DNP, we know 2,4-dinitrophenyl hydrazine. We know that is Brady's reagent, and we use it to test for carbonyl compounds. We know it cannot differentiate between aldehydes and ketones. It just tests for carbonyl compounds. So both the aldehyde and ketone, it can detect it. So compounds E and F, what we know so far is that they are both carbonyl compounds. It says no, however, only compound F formed a silver mirror with a solution of silver nitrate. All right. Now we know that the silver mirror test is used to distinguish between aldehydes and ketones, and it is the aldehyde that will form the silver mirror. So we know that one of these, compound F, is the aldehyde, and compound E is a ketone, compound D is an alkene. A and B are both alcohols, not the same alcohols. Now, the first question, it says we should state the type of reaction which produce compound D and write its structural formula. So the type of reaction that produce compound D is dehydration. That's the reaction. The structure of compound D. All right, let me draw compound A and B first. So we know compound B is an alkene. So after that question, they had asked us to explain the reaction to produce E and F, and then we should deduce the structure for E and F as well as A and B. So we have to deduce the structure for E, F, D, A, and B. All right. But the first thing they had asked us to do is to write the name of the reaction and the structure of compound D. All right, so let's start. So phenyl tells you it's a benzene ring. Just going to put a circle. All right. Now phenol would have the OH group. All right. But phenyl is the term used because you know benzene is C6H6. All right. So it would have 6 hydrogen. Now phenyl is when one of the hydrogens has been replaced. So phenyl is C6. Phenyl is C6H5. That's phenyl group. C6H5. So a H would be here. H, 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 H again. But no H here. So we use 6 carbon atoms out of a total of 8. So that means a carbon atom must be here and the next one must be here. So a straight chain, straight carbon chain here. So that is the benzene ring with 6 carbons. So the remainder of it is the chain. Now it must be an alcohol, right? So one of these carbon atoms must have an OH group. At this point, it doesn't matter where the OH group is. When you react it, all right, let me put it here. So let's say the OH group is there, all right? Hydrogen would be there, hydrogen, hydrogen, hydrogen. If you dehydrate this compound, remember reactions take place at the functional group. So in this case, the functional group, here you have the alcohol. So if you dehydrate it, you are converting it to the alkene, which is this. All right. That is what you are going to get. So this is compound D. So that is one possible structure of your isomeric alcohol. Let us check if we have 8 carbon, 10 hydrogen, and the oxygen. So we know 6 carbon is in the ring at each, well, if you haven't done benzene as yet, at each point in the ring is a carbon. So 1, 2, 3, 4, 5, 6, 7, 8. Then we have 5 hydrogen plus 3 more. Let me just put it on it. 5 and 3, that is 8, and 1, 9, plus the 1 hydrogen and the OH group, that's 10, and the 1 oxygen atom. So this structure, it matches the molecular formula. All right. So this is the structure for compound D. It has lost a molecule of water. So remember, in dehydration, a molecule of water is lost. All right, so you get your alkene. So we have converted the phenyl alcohol to an alkene. That's compound D. Now it says explain, so let me just write it. All right, so part 2 of the question, it asks us to explain the reaction that led to the formation of E and F. Now remember we said E and F are aldehydes and ketones. Well, E is the ketone because it did not react with it did not give a positive test for the silver mirror, right? Reaction or test. But compound F formed a silver mirror, which makes it the aldehyde. So how was compound E? Explain the formation of E and F. So we have two alcohols here, A and B. Obviously, one of them is a primary alcohol, one of them is a secondary alcohol. We know that primary alcohols are oxidized to aldehydes. If you make it stay long enough, you will get the carboxylic acid. So you just need to explain that primary alcohols are oxidized to aldehydes. Secondary alcohols are oxidized to ketones, right? So if F is an aldehyde, that means alcohol B. I will not even have to go there yet. If F is an aldehyde, it was formed from the oxidation of a primary alcohol. E is a ketone, so it was formed from the oxidation of a secondary alcohol. So that's it. F is the aldehyde, it is formed from the oxidation of a primary alcohol. E is the ketone, it is formed from the oxidation of a secondary alcohol. And I typed out the answer here for you. All right, so now they want us to deduce the structural formula of E and F, A and B. So F is the aldehyde, so let us just do that. So remember, what's going on here? So aldehydes are aldehydes and ketones. So remember, this was the structure of compound A. So A is the secondary alcohol and B is the primary one. So this would have been oxidized to a ketone. So we just need to change this carbon here to a ketone functional group. So we just need to change it to double bond O. All right, everything else stays as is. So put on the hydrogen, hydrogen, hydrogen. All right. So that's your ketone. That would be compound E. Compound F is the aldehyde. Remember, if you don't put in the ring, that's not benzene. Okay, so C. C. Double bond O. So with the aldehyde now, remember that would be at the end, it is formed from a primary alcohol. So the primary alcohol, the OH group would be on the first carbon. So that is compound F. This is your aldehyde. All right, so I already had compound A, so all I need to draw is compound B. So all we're doing now is shifting the position of the OH group to carbon number 1 to make it the primary alcohol. So that is compound B. So compound B was oxidized to compound F, primary alcohol to the aldehyde. And compound A, which was the secondary alcohol, it was oxidized to your ketone. All right, so that's it. The final question was to comment on the reaction of A and B to plain polarized light. Comment, let me just write that. All right, so the final question, it was to comment on the action of A, compound A and B to plain polarized light. So once you see that, you should know they are talking about whether compound A or B is chiral. Remember, chiral compound should have been a chiral carbon, and the chiral carbon has 4 different groups attached. So this carbon has 3 hydrogens, so it cannot be chiral. Then none of these in the ring are chiral either. But this carbon here, it has a methyl group, it has a OH group, it has a hydrogen, and the entire benzene ring, right? We consider that a group. So this carbon is chiral, it has 4 different groups, right? So this alcohol here, it has a chiral center, so it will rotate plain polarized light. If we look at compound B, this carbon with the OH group, it has 2 hydrogens, 2 same groups, so it cannot be chiral. This one, 2 hydrogens. These have 2 carbons on both sides. So these carbons in the ring are not chiral, right? But this is not chiral either because it has 2 hydrogens. So compound B is not chiral, it will not rotate plain polarized light. Compound A, it has a chiral carbon, so it will. And that was the end of the question. So it was 1 mark to comment. Each of these structures is worth 1 mark as well. And to explain what led to the production of compound E and F, which was the oxidation of primary and secondary alcohol, that was worth 2 marks. The structure of compound D and the type of reaction, that was also 2 marks. So that was question 4, all of it. All right, so that's it for this video.